everyone, my name is ELYSSA Olivares and we are here today to make a simple code implementation in queue abstract data type using linked list in Python. Take a look at this code. Here, learning task 3, implementing a queue using linked list in Python. We all know that queue uses the principle FIFO, which first in, then first out. In the concept of linked list, we are using two elements, which is the head and the pointer. So, in initializing or creating a node class associated with linked list, we are going to have a self and value that will represent the two elements that are needed in our linked list. Here, we are going to make a class named node, then create a function that initialize self and value, which self.value equals value, then self.next equals to none. In here, you can see that self.value is equals to value and self.next is equals to none, since we don't have any element on our queue, and this part is just creating a blank queue that is associated with our linked list. Here we have another class which is for the queue or the functions that we are going to use in our queue. First, we are going to create queue's empty pointers, front and rear or tail. In queue, the first element is called the front and the last element is called the rear or the tail. Here we are going to create a function which initializes self.front equals to none, then self.rear is equals to none, since our queue is still empty, or we are just creating a blank queue. Then, to check if our queue is really empty, we have here a function is empty self, then it will return self.front is none. We have a condition here which it displays empty if our queue is really empty. In the operation of queue, we have NQ and DQ. Here in NQ, it is simply adding an element to our queue, which we have a function NQ self value new node equals node value. Then we have here a condition which if self.rear is none, then self.front equals self.rear is equals the new node, or it will be the new node. If here in this condition, if our queue was just having one element, then it will be considered as the node or the main value, and it is considered as the pointer also, since in linked list we need two elements for the head and for the pointer. If we only have one, then it will be considered as the head and also the pointer. Else if self.rear next equals new node, then self.rear is equals to new node. Or it is simply if you put a value on the queue, it will be the value of the queue. Here in removing element from the queue, which is also called DQ, we are it has a function which also the queue self. If self is empty, then return none. Here if our queue is empty, then it won't since our queue is empty, then there's nothing to be removed on our queue, and it will return none. Here in temp self.front equals temp next. Then if self.front is equals to none, self.rear equals to none, return temp value. Here we have here in this part we have here a condition that will display if our queue is empty, and if it's empty, then we aren't going to perform a DQ for it, since we can remove something or we can remove in our queue if it doesn't have a value. Here in displays the status of the queue, we have here a function display self. If self is empty, return empty. This is what I'm saying, that if our queue is empty, then it will or a statement will appear like this, empty. It will be more visualized in our code. Then temp equals self.front values, while temp values that append temp value return join map. Here in adding elements on our queue, you can see that every every in our code, in our output rather, we can input 3 queues, or we can put elements on our 3 queues. For us to be able to put multiple elements in our queue, we are going to use these functions, these join map string values. Let's come now into the program, or the code for displaying and the inputs that will appear on our output if we run the code. Here we are going to make a function main for our code to be read as one and to be more organized. Then we are going to set the functions to every queue. This q1 to q3 equals to q. That q is our class in the upper part, for it to read, or for these 3 function of that those functions will be used in implementing this q1 to 3. In displaying the status of the queue and the menu, we have here q1, q2, q3, which first in our output, you can see that the status of the queues will be displayed if it's empty or if it has any value. Then after displaying the status of our queue, in the lower part, you can see the menu where you can exit enqueue workload, or you can add an element to your queue and dequeue if you want to remove an element from your queue. Then here, conditions for choices in the menu. This part is for the menu, which you can choose, or you can input 0, 1, and 2. That indicates indicates conditions where if you chose 0, then it will print thank you, then the code or the output will end. Then if you choose 1, then you can input a value of here you can input the value of the workload, which you can add. Since it is for enqueue, you can add an element to your queue, and in this part you can use this multiple times as long as you are not choosing 0 on our menu. After the enqueuing, rather, you can also remove an element to your queue. It is the function for dequeue, which if you chose 2 on our menu, we have here a condition which if it's empty, or if it has any value in it, then it will be removed. Since in removing an element from our queue, it is you can specifically remove an item from your queue, but as long as the order of your queue or your desired element that you want to remove on your queue is on the first element, since we are using the FIFO algorithm. Then that's the end of the code. Let's go now into running the code to help you visualize the output. Terminal, then here in our output, as you can see, the first ones that will be printed are the status of our queue from q1 to 3, which is empty since we're just starting our code, or we're just starting to run it. Then the next lines will be our menu, which you can choose to if you want to exit, enqueue, which refers if you want to add an element to your queue, then dequeue, which refers if you want to remove an element on your queue. Since we're just starting, we're going to enqueue, then I will, or add in our queue, then I will put 1, then enter, then it will display input the value of workload. It denotes to what are you going to insert in your queue. Let's try 3, then enter. As you can see, it will automatically print your input in q1, which is 3, as you can see. Then it will print again the menu, which you can again choose. Then since we're just starting, then we're just going to enqueue or add elements. I will try 5, then enter. My bad. I was confused, sorry. As you can see, if I put 5 in the choices from the menu, which has only 0 to 2, then if I put 5, it will be just disregarded. Then it will print again the last output, which is this. Then again, since it is not on the choices, on our choices, then I will put 1 to NQ or add. Then again, input value of workload, I will put 5, then enter. As you can see, our second inputted value for our workload, which is 5, is on our queue number 2. Then the Q3 is still empty since we are not yet inputting our third value. Then again, the menu is displayed. I will choose 1 to NQ. Then input value of workload, I'll try to put 2, enter. Then as you can see, on my third input, it is in our queue number 3. Then the menu again, I will choose 1, then I will put 1. As you can see, through inputting our values on our queues, it will be, what you call that, it will be our first value inputted rather will be count in Q1, and our second value inputted is counted in Q number 2. Then our third value inputted is on the Q number 3. Then since the Qs are only 3, the fourth inputted value will be counted in the Q number 3. Let's see what happened if we put another value, or our fifth value. I will put 4. My bad, it's the choices. I will put 1, then the workload 4, then enter. As you can see, it is still counted on our queue number 3. Let's see if what happened if we put here in our, or we NQ another variable or value in our queue, which is the 6th value. I will choose 1, then I will put 2, then enter. Here, our since the values are the values of our first, second, third inputted values are in the Q1, Q2, and Q3. As you can see, the 4th to 6th elements that we inputted are on the Q number 3, or it stayed in the Q number 3. What if we dequeue or we remove an element on our queue? Let's put 2, then enter. Then the queue, since Q is mainly uses the principle first in, first out, since 3 is our very first value to be that we inputted, then it will also be the first one to be removed or to be dequeued. Then another I choose 2, then enter. Then our queue number 2 is empty since it is the second one. This is the second value that we inputted. Did you realize that it's like when you go to a grocery line, which the first or the person that is in front of you will be the first one to pay his or her groceries. Then if she or he lived, the next person on the line will be the next who will pay for his or her grocery. If we put 2, then enter, then our third element will be removed since it follows the queue principle. Since we are done on trying the NQ and DQ, or the concept of that queue's operations, we are now going to end the code, which we are going to choose 0 on our menu, then enter, then it will display thank you, and that's the time where the code will end. And that's all for the implementation of queue using linked list in Python. Again, I'm ELYSSA Olivares, and this is my output for learning task 3 in implementing queue using linked list in Python in data structures and algorithms.